Welcome back, fellow problem solvers. John East here. With mathematics, as you know, it's lots of fun. So triangles, quadrilaterals, congruency, similarity, what in the world am I talking about? So and you will find out more if you stay tuned watching this video. Share, like and subscribe. Good day, fellow problem solvers. Hope you're doing well. So yes, today we're starting off with a new section called congruency and similarity. And what are we talking about and how do they compare with each other? So first up, congruency. I enjoy explaining congruency as the following. It's when objects are equal to each other, but they are super equal to each other. And this is the symbol for congruency. 3 horizontal lines, so that means they are equal in every aspect. If you look at these two objects, the triangle on the left, the triangle on the right, you would have noticed that I literally just copied the one triangle and I made a duplicate on the right hand side. So these two are perfectly the same in every aspect. This angle is equal to that angle. In other words, corresponding angles are equal. This angle is equal to this one. And then the third angle is also equal to this one in its corresponding form. You will also notice that the longest sides are exactly equal. The second longest sides are exactly equal in size. And the third longest side, well, the shorter side, is exactly the same as the other shorter side. So these two triangles are exactly the same in all aspects. Okay? So how do we remember this? Congruency is like a super equal to sign. It's like an equal to sign underlined. So that means all corresponding angles are equal. And remember, this doesn't only apply to triangles. This applies to quadrilaterals as well. Secondly, all corresponding sides are equal. Remember, I'm introducing you to the concept, but also the symbols and the notation. So remember, the sign congruency is the super equal to sign, and that will help you to remember it. If I would quickly just take an example of using a quadrilateral, any quadrilateral like this, and again, that is when they are exactly the same. These two sides, shapes, are congruent. Corresponding angles, all corresponding angles are equal, and all corresponding sides are equal. Okay, secondly, let's talk about similarity. So similarity is when we've got similar sides. Well, if you look at these two, you can see they're exactly the same. But what if I do the following? I am now changing the size of the triangle on the right hand side. But take note, if we are comparing angles, let's say angle A with angle D, and angle B with angle E, and angle C with angle F, angle A is the same as angle D. The angles did not change. Okay? The actual shape, the size of the triangle changed, but the angles did not change. Angle B is still the same as angle E. And angle C is still the same as angle F. But you will notice here the sizes are different. And that's where the actual sides come in. Okay? So AB is in proportion to DE. In other words, let's assume this was 1 centimeter, 2 centimeters, and 3 centimeters. And I doubled the triangle. That means this side became 2 centimeters, This one then has to be 4. This one has to be it will have to be equal to 6. Okay, so we doubled the triangle in size, but the angles are still the same. And that would help you with the properties of similar shapes or similarity with triangles. Now, first of all, the symbol here is also 3 lines, but they are vertical lines. Think of that L there, similarity. That will help you to remember that they are vertical. Okay, so what are the properties? All corresponding, and you can probably complete the sentence for me. All corresponding, what are the same? Angles are equal. Secondly, all corresponding sides are in proportion. So they're not equal, but they are in proportion. This is a big word. I'm not sure if everybody knows what this means. Let me just explain briefly. If you look at this triangle, and I would say side AB over side BC should be equal to side DE over EF. Let's test to see if that's true. AB is 3, BC is 2, and DE is equal to 6, and EF is equal to 4. Now, this is the same because 6 is 3 times 2, and 4 is 2 times 2. So these two will cancel out. And as you can clearly see here, it's exactly the same. Let's look at another example in proportionality, because this is also true for the other set of corresponding sides. So we will look at AB over BC, and then corresponding will have to be then, well, we are not comparing BC, but we are comparing AC. Okay, AB over AC. Now the other side, we are comparing DE with DF. So over here, AB over AC is equal to 3 over 1. DE is equal to 6. And DF is equal to 2. Now, if we take out a common factor, 6 becomes 3 times 2. The 2's cancel out, so this is equal to 3 over 1. As you can again see, they line up perfectly. So there we go. This is similarity in comparison with congruency. Stay tuned for more.